Welcome to lecture number 39 of part 1. Just one or two more classes pending here. Replacement of a force acting at any point by an equivalent force and couple at some other point or at any specified point. Heading, that is, make a note, a force is acting at some point. We want to remove that force from there and apply it at some other point. But what will happen is, not only force, there will be a couple. So what force you are applying at a new point and couple you are applying there, that is equivalent force and couple at some other point. And also, this is for a single force. See, I told of a force means single force. And also, replacement of a given force system is any number of forces by an equivalent force and couple at any specified point. Any specified point means wherever somebody wants it. Remember this one of the very important concepts in structural engineering. That is replacement of a force acting at any point or a force system by an equivalent force and couple at any required or specified point is one of the most powerful you require for RCC, steel, RCC footing you require, pre-stressed concrete, everywhere you are applying in structural engineering. Okay, now, first start. Consider a force P acting at a point A in a rigid body as shown. See, some rigid body is there. Take a point A, apply a force P. Now, suddenly, somebody will ask, sir, why you mentioned rigid body? Reason. Because engineering mechanics, we always consider rigid body. We do not consider deformation. But actually, I will tell you, in the derivation, you are taking rigid body. No deformation, nothing. But see, class, brain teaser, it will come little later. I will ask a question there. When you replace a force acting at any point by an equivalent force and couple at some other point, you are considering rigid body, yes or no? Yes. But you do this one for RCC column, RCC footing, then steel also, in steel structure, eccentric corrections. I'll give examples here. And steel columns and pre-stressed concrete, when the cable is eccentric, you are all using it. Yes, sir. Are they rigid? No. Then, when you derive, you tell rigid body, but later when you apply, you are applying for a member or any structural member which is not rigid. How you will justify it? Yes, there is justification, but not here. In structural engineering, you right now, you consider rigid body, that's all. Brain teaser, I will ask. Majority will not tell. They will tell, yes, correct, but I never thought. Now think. Okay, start. Consider any point A. See, A, B are random point here. Some point A is a rigid body. A force P is acting down, up, right, left, incline, anything you can take. Understanding purpose, apply a force P. Now, consider another point B in the same plane. Let A be perpendicular distance from B to line of action of P as shown. See, this is already applied force P here. See here, force P is applied to A. Take another point, wherever you want, but in the same plane. Another point, so that from that point, if you draw a perpendicular, the perpendicular distance to line of action of P is A. Now, see, as shown. Now remember, you can make a small note here. I will write here, see. This is, you write here, original point where force P is acting. You make a note. This is that point where you want to introduce equivalent force and couple. Or you can write one more statement. Force acting at P, force P acting at A, we want to replace by force and couple at B. This is the original point. This is the point where we are going for replacement. Or we want to shift the force acting at A to a new point B. In the notes I will write. Here there is no time to write all. Write it. Or now to find equivalent force and couple at B. Or imagine required to replace the force P acting through A by an equivalent force and couple at B. See, what to do is introduce the same force P through B parallel to P. One of them introduce the same one of them in the direction of P and other opposite direction of P. Or it introduce the same force P, you write twice through B. One of them, see, if a P is here, see, this is the green color, black is original color, this is a green color. Green color is same as P, red color is opposite to P, as shown. Now, some statements are there. In the notes I will write, here you should write. Now, if you see here, this green color P and red color P, they are collinear and what? Acting in opposite direction, same magnitude. Their resultant is 0. Therefore, this P and P will cancel, but don't cancel, they will cancel each other. See, this green color P and red color P will cancel each other. Therefore, there is no change in the effect on the body, rigid body, by introducing these two forces. Just like, see, I will tell you what you are doing. You have one note here, 20 rupees note. Put one more 20 rupees note and take it out. So what happened now? Put one more 20 rupees note and take it out. One incoming note, one outgoing note. So effect of this remains same. Okay. Write the statement here. Note just write. Now I will rub. What I will do is, now I will write this system. This is equal to this one. I will write one more sketch here. This is equal to that one. Then I will explain further. This I will come little later. I am removing everything from here now. Now see correctly once again. This is the original. Make a note. Force P is acting at A. Now, what you have done? That force is there. When that force is still acting, you introduce downward P and upward P. Don't tell downward, upward. One in the direction of P, other opposite direction of P, but same as P through this point. One green and one red color. Now, this will be equal to this one because these two will cancel. But don't cancel. If you are cancelling, then why you are applying? Okay, over. Now, some statement you have to write. See here. Statement you have to write. Here, what you will do is, first to consider this red color P and original P. Or right here. Now consider this you divide into two parts. In the first part, you consider original force P at A and the opposite force P at B. See, this one and this one you consider here. See, plus this P you have to consider. First you consider original force at the original point P and opposite force at P at B, and then the force in the same direction as P through the point A. Sorry, this is B. Oh, sorry. This is B. This is A. Over. Now write here below. You should write. See, in the notes, there is no space problem for me. I can keep on writing. Now, see here. Two equal unlike parallel forces. P down, P up. So here, net force equal to 0. So this will result in a couple of magnitude P into A. This is already explained in the previous class. I won't waste time. P into A. In this case, clockwise. Don't by heart clockwise. Here it is clockwise. If the force is that side, I will give example for you. See, P into A. Okay, clockwise. Plus this force P is there. Or this is the final. See, this is the final. So your original force at P, when you replace to point, this is B. Okay, this is B. This is B. When you replace the point at A to B, you get a couple P into A and also the force P. Or if we have to, replace the force P acting at A by an equivalent force and couple at B, any point B, then we have to consider the same force P through B and also a couple of moment equal to P into A. In this case, it is clockwise as per this sketch, clockwise. Now I will give final statement for you, and then I will give some practical examples where it is used. Only for that practical example is only for those who are studying structural engineering. Otherwise, other people can ignore it. Or lastly, you write the summary. Then I will go to examples. See, put the summary. I'll tell words. I written because time saving. Force acting at any point in a rigid body can be replaced by an equivalent force and couple at any other point. But to make it more clear, or you can tell a force acting at any point in a rigid body can be shifted to any other point along with the couple. See, force can be shifted means shift the force. If the force acting, shift the force. Along with means what? Force will come. Along with, you go there, along with him means you also go there. Along with a couple whose moment will be equal to moment of the force about the shifted point. Now I will give, to make it more clear now, some numerical example. It is better to give numerical example so that it becomes much more clear. See here, correctly see here what I am doing. This you write, see. See, therefore, imagine there is some rigid body is there. I want to show a rigid body. Okay, this is a rigid body. A force of 10 kilonewton is acting here through a point. You write here, consider a force of 10 kilonewton acting through a point A on a rigid body. Okay, little bit bigger. I write here. Little bigger. Okay. We want to shift this force to a new point called, I will call A dash, and one point here called A double dash. A double dash. This distance, perpendicular distance, see, this is a perpendicular to this force, is 3 meter. Imagine this is 4 meter. Right here. 10 kN force is right here, originally acting. This is the original position. See, 10 kN force. Why I put kN? Because structure engineering always kilonewton comes. 10 kN, you should write 10 kN force is acting at A original. Now somebody wants to shift it to A dash or A double dash. 1 point here, 1 point here. See, then see, replacement at A dash by equivalent force and couple at A dash, or you can tell what? Shifting 10 kN acting at A to A dash, the 10 kN acting there to A dash. Answer is, see, this is the point A dash. Originally, see here, 10 kN is acting here, origin, light line, now it is going, see, this way. See what you do, stand at A dash, 10 kN, see correctly, you tell, come here. You shift it right here, shift the force as it is. You should write it, shift the force as it is. Then hold the finger at A dash. Force will shift here. See how much it is? See, force is 10 kN only, but there is a couple of 10 into 3, see, clockwise, along with a couple of 10 into 3 equal to 30 kilonewton meter. This is shifting of 10 kN at A to A dash. Now, okay, correctly make a note. I'm rubbing now. See now, replacement at A double dash by equivalent force and couple at A double dash. One more sketch you are right. Or shifting 10 kN acting at A to A double dash. Where is A double dash? Here. A double dash. Okay. This is original force here. Stand here. Go to the point where you want to shift the force. Make a note. I am not repeating again and again. Okay, then shift the force as it is. Come here, you come here. It will come. Okay, come here. 10 kN. Then also moment about this point is 10 into 4 is anti-clockwise of 40. It is falling down because it's so simple why you are explaining. Okay. Along with an anti-clockwise couple of 10 into 4 equal to 40 kN meter is the effect at A dash. That's what you have to do for shifting a force acting at any point to any other point. Now, I will give, see that I have still not touched there. What is this one? So this is, okay, this is later. That will come later. That statement don't see now, time being. Now, this is over. I first give some practical examples just for those who want to learn structure engineering. Other people go forward. It is incomplete now. Go forward. See, first, consider only for those who want an RC column. See, RCC column. No, not correct. Okay. 3D view. Column is there. Okay. Cut. Okay. See, some axis required here. This is, I am not explaining too much because this is engineering mechanics. See, you write here some practical examples. Some practical examples, and you have to write one more thing. Here briefly write more and detailed explanation will be given later in respective subject like RCC, steel, or pre-stress concrete all, or RCC footing all. It will be given later. Right now, briefly. See. Now, okay. Right now, see. This is, imagine, this is YY axis. Remember, this XX axis in the cross section. What is cross section? All you don't bother now. This is for structure engineering. See here. Now, imagine a vertical load P is acting here. P. This has got eccentricity of, see, E along x-axis, EX. This is called uniaxial. Those who want can write. If you want, you write uniaxial. This will be equal to, see now what happens. This is equal to, when you go for RCC design, I'll tell you what people are doing. See, I'll tell what they will do. They will mark XXYY once again here. YY, see. This is the CG, centroid of the cross section. So the force P, they will shift here. How? Directly they will shift here by an axial force P, and about YY axis, a moment of P into EX. So, and a moment this way, which is called M about Y axis equal to P into EX. That's what they will do in RCC. Okay. Now, second example. No much explanation. See, your theory is clear. From here, shift the force with the couple, M into E. That's all. Those who know structures, they will understand much better. One more, for biaxial, see, just for information only. Then I will come back to once again our subject, engineering mechanics. Cut the column. Height, you are not interested. See, once again. X-axis, YY axis. Imagine the force acting here, P. Oh, this time the force is having, see, from here, an eccentricity of EX along X and eccentricity of, see here, EY along Y. This is called biaxial. Those who want to understand, biaxial. This will be equal to, see, what in the RCC we will do is, I am telling what in the RCC we will do. Other people just ignore it. What I am telling, just ignore now. Don't hear anything. I will shift the force from here to here. First I will shift it to this line, this axis. See, shift here. It will be force P here, axial force P. It will create a moment like this of, see, a moment like this of moment about y-axis. Why it is about y-axis? This all comes in RCC of P into Ex. And also about x-axis, it will create a moment like this. See, it will create a moment like this about x-axis, mx equal to P into Ey. Those who know RCC understand. Those who do not know, or if you do not want to know RCC, just ignore these 5 minutes, you don't bother. Okay. Now, further, when you go to pre-stressed concrete, pre-stressed concrete, this is the longitudinal centroidal axis. It's a beam. A pre-stressing force P is acting here at an eccentricity E. Same, this is through a cable or tendons P. This also is equal to eccentricity E. This will be equal to, what they will do is, statement will be there in the PSC, pre-stressed concrete. See, this is your longitudinal centroidal axis. They will tell the eccentric force P will be shifted to longitudinal centroidal axis or through CG of the cross section. See, this P here will be shifted here. It will be equal to P here. See, and a moment P or couple P into E this way. P here and a couple this way of P into E. Same way there, this P is shifted here. P and a couple P into E this way. P. Now, this P is called axial force. This P is called end couple, which will create a bending moment. P by A plus or minus P by Z is a stress function. That you don't bother. Somebody may ask me, sir, you told longitudinal centroidal axis. It is not through midpoint. Who told it will pass through midpoint? It can be unsymmetrical section. CG is somewhere here. Did I tell that one? No. Then don't answer. Don't question. I did not show that section. There is no rule that longitudinal centroidal axis will be through what exactly mid height. It can shift to one side. You understand what I told. Or see, one more. In steel structures, also you require same thing in a base plate all and also extra. Imagine a bracket connection. See, bolted or welded. Okay, I'll take bolted. You never bother about these things now. A force P is acting here. Cut, column. This is a column. Bolts are here. How many bolts we don't know. This is the eccentric connection, sufficient eccentric connection. What people will do is equal to, see here, where shall I will put here. Okay, there no place there. Okay, no place to write. Okay, I don't want to remove that one now. Okay, here I can write, okay, here, okay, equal, I see here, okay, equal to, okay, little shifting I am doing, okay, don't see those things, see. This force P will be shifted to CG of the cross bolt group. This is the CG of the bolt group. It is here. CG of the bolt group. What they will do is the PC from centroidal this axis, this is called eccentricity E. Now the P will be shifted here by axial force P and a couple M or moment M equal to P into E. P into E. This is for bolted connection. Same thing for welded connection also. But I don't want to show because why? You are not doing steel structures here or RCC. Make a note. Now, important concept once again. back to engineering mechanics. Okay, see here. Now come to system. See here. Now come, I earlier told how to replace a force, one force I told. Now, replacement of a given force system by an equivalent force and couple at any specified point. What you have to do is, see here, same principle. Same principle, but repeated several times. But shortcut is there several times. Shift each and every force to required point along with the couple. Shift each and every force to required point along with the couple. Or shortcut directly. Replace the force system by a single force and then directly shift it. I will make it clear, don't worry. Either you shift each and every one, directly shift it. When you replace by a single force means, actually single force means resultant force, not result, and then directly shift it. How? I will tell. How? Wait. I am giving example. Now I am giving full example here. How to shift a given force system to any new required point. 1 minute. Start now. This is the given example 1. Question 1. Replace the given force system. See, 4 forces are given. I will start from simple and go to little more difficult. Not difficult actually, everything is easier. By an, not a. By an. I told I usually never make grammar mistake. By an equivalent force and couple at O. O is a new point. They wanted 1.5 from here. See, this is a given force system. Somebody wants to shift it to point O. Okay, now, option 1. Very simple. Successively shift force by force. Now, I will dictate something. You have to write it. Because in the notes, this will come around 4 or 5 pages. Here, I will dictate. See, start. Consider 100 Newton. From O, it is at 1.5. 100. Shift here. 100 down and a clockwise couple of 100 into 1.5 equal to 150 Newton meter. Equivalent force and couple at O due to 100 Newton force acting at A. Next, consider 150 Newton force acting at B. Distance is 5.5 meter. Shift it here. 150 and a couple of 150 into 5.5 equal to 825. Equivalent, same thing, force and couple at O due to force acting at B. Same way for C, distance will be 1.54 plus 3 into 8.5 meter. So you get this answer, 775 and 637.5 due to 225 Newton, 1.5, total is 10.5 meter. Okay, so it becomes 225 into 10.5 force with the couple. Okay, now, therefore, considering shifting of all the forces, what happens? See only below. Don't see that one now. Now this is cancelled. This is cancelled now. See below. 100 down, 150 down, 75 down, 225 down, 550 Newton down, and clockwise 150, clockwise 825, clockwise 637.5, clockwise 2362.5, all together clockwise of 3975 Newton meter. Therefore, you write the result. I will dictate now. If you replace the given force system by a single force and couple or equivalent force and couple at O, then we get a vertically downward force of 550 Newton through point O along with the clockwise couple of 3975 Newton meter. This is the principle. Okay, now this is very lengthy procedure. So what you can do is, you can do it easier way. Instead of option 1, we go to option 2. Option 2, which is the best option. I will tell what is option 2 now. Here only. I am not changing anything. So remember the answer finally. What you got? A downward force of 550 and a clockwise to the point O, clockwise of 3975. Okay, sufficient. Directly. See, what you do is, I will give now statement for you. Option 2 or best option right here. Option 2, that is best option. Now onwards, in any question, we will do option 2. We won't waste time option 1. Now onwards, option 2. What to do is, find resultant force with the direction. Remember, line of action not required. Line of action, because you are shifting it. Line of action is not required. We are not interested to find, see, line of action required when you are locating the resultant. We want only resultant force. Okay, then shift that resultant force itself to the required point. Shift that resultant force itself to required point. But now, so therefore force shifted. So that is actually force effect over. You can remember, force effect over. Now couple. Very simple. Find algebraic sum of moments of given force system about the point. See, I am writing big about the point where we want equivalent force and couple, or about the point to which we have to shift. Over. What shift? What I am telling all these days, shift the given force system. We have to shift. That's all. That algebraic sum of moments itself is couple to be considered. Over. That is a new principle. I will tell once again now. Briefly, make a note. Then I will solve the same question with the option 2. Then one more class required where I will go for multiple one. Next class is a winding up class. Most probably part 1 is getting close to next class. Today is the last but one class for class. Which one? Part 1. Now once again I will tell. Procedure. Find the magnitude of the resultant force with the direction, that's all. No line of, write big letters, no line of action required, because we are not locating the resultant completely, we want to shift it. So what you do, find the magnitude and direction of the resultant force. That is very easy. That itself is, you shift it to required point. Then find algebraic sum of moments of the entire force system about that point to which you have to shift. That algebraic sum of moment itself is the couple. That's all. Okay, start now. Now option B, see how fast it is. Option 2, resultant force. Resultant force for given force system. Tomorrow next class I will do more questions with where some forces are up and down are there. And I will even do coplanar force system. Force system equal to, don't write R, equal to, see, okay, write R if you want. R equal to, I will take downward positive. Why? All are downward, equal to 100 plus 150 plus 75 plus 225, that is equal to same 550 Newton. 550 Newton. Therefore, resultant magnitude is 550 Newton, direction down, over. Then, algebraic sum of moments of, this pen is not writing, I would change the pen, okay, of given force system, now it is writing, given force system about O. Why O? Because the question is replaced by equivalent force and couple at O. At O equal to, take clockwise positive. See here, 100 into 1.5 clockwise plus 100 into 1.5 plus 150 into 1.5 plus 4 is 5.5. 150 into 5.5 plus 75 into 5.5 plus another 3, 7.5. So 75 into 7.5 plus 225 into 10.5. That's correct. So this is 8.5. Also you see 8.5. 1.5, 5.5, 4 plus 3, 7, 8.5. Then only same answer will come. 225 into 10.5. Actually checking is not required. Let me check it, because the previous, by mistake if I take 7.5, now you can make out. Then 100 into 1.5 plus 150 into 5.5 plus 75 into 8.5 plus 225 into 10.5. 3975 plus 3975 Newton meter. That is, it is what? 3975 Newton meter clockwise. Why? Because clockwise positive, over. Therefore, equivalent, over question, equivalent force and couple at A, at O will be as shown. See, as shown. Point O is here, other points are not required. Force, whatever is the force effect. 550 Newton and a clockwise couple of, how much? 3975 Newton meter. Okay, now one small interesting point I will tell for you. This will come for you later in strength of materials. Okay, this over now. Let's see. One small important point. Right, you consider a cantilever beam. Cantilever beam. A load of 120 kilonewton at 3 meters from here. AB is a cantilever. Remember, if it is not clear, it will come in strength of materials when I go to SFD, BMD and support. No, Engineering mechanics it will come when I go to support reaction. Time being, believe me, but 99% people are knowing it. Now, see, we want support reaction. See, remember now, it is not covered still, support reaction at A. Those who know E1 little also will get the answer, they will tell if you apply load of 10 kilonewton here, A, B, they will tell there is a vertical reaction VA of not 10 kilonewton, 120 kilonewton. There is a vertical reaction here of 120 kilonewton. They will tell there is an anti-clockwise reacting moment MA of 360 kilonewton meter. I am not, this you will get later in engineering mechanics. Okay, now think a little. You are applying only a force. Why a couple came? You are applying only a force. Why a couple came? Reason is the force is acting at B. When you shift it to A, see, when you shift the force to A, see what happens is this 120 kN, if shift to A, it will have a force of 120 kilonewton and a clockwise moment of 120 into 3 equal to 360 kilonewton meter. This is the effect. This is the effect of 120 kN at B at support A. Support A. Or this is called action. Remember, this is called action. If you apply a force of 120 kN, it will push the support down by 120 kN and will try to rotate by 360 kN meter clockwise. Now for equilibrium, support reaction. Reaction is opposite to action. Action and reaction are equal and opposite. We all will learn it later. That is why when it is pushed down by 120, support give an upward reaction of 120 for equilibrium, and when the rotation, when an action of 360 kN meter, when that load try to rotate the support by 360 clockwise, see, 360 clockwise, support give reaction of, for equilibrium, 360 anti-clockwise. If not clear, leave it. Don't worry. But I told now, that's all. But 99% people understand. Okay, now, next class, I will make last class for this equivalent force and couple, little lengthy, 2-3 examples I will take, that's all. And then I will go to second part, equilibrium, and when the last class is over, within around a week's time, I will start sending the notes. I will make one more class there. After our announcement of the notes, I will announce. Up to date, everything is almost, this one, today I have to write. Why? I never prepare. I will see the recording and then see what I told in the class, I have transferred to notes. What I told you, whatever done in the class will be in the notes. If I prepare the notes earlier, I should bring the notes to the class. I never bring anything to the class. So I will announce, notes is ready, and once again I will give procedure, those who want to get the notes, what to do, I will tell on that class. That is after the next class. It is not the class number or lecture number, it will be separate uploading. Details of issuing of the notes. And I will tell you importance of the notes on that day, not now. Okay, thank you. See you in the last, almost concluding class of part 1, that is next class.